So let's see whether the capacitor really blocks DC. So before going to that, just going for some basics. What is current? You know that the current is nothing but flow of negative charge or electrons, and I'm going to make it practical. So taking case 1, so here you can see there is voltage source connected to a bulb, and the current flows in there is negative charge, this is positive and negative, and the electrons flow in this direction, here to here, here through the filament, and here. So this circulation of electrons is nothing but the flow of current. That is what we discussed here, flow of negative charge. Here there is negative charge is flowing through this path, so it will glow the bulb, and here in the circuit the current is flowing. Let's take another condition where some part of the wire is broken. So here you can see the electrons will come here through here, but there is no barrier for them to move forward. Here it is broken. So what will they do? There is no because of this there is no current flow. So this situation is nothing but the open circuit condition, but there is voltage across these two terminals, because here the voltage source is pushing the electrons to here. They are having some potential, so that potential can be measured by connecting a voltmeter across those two terminals, but there is no current flow. That is, current is equal to 0 in that case. So let's take another case 3. So here can you guess whether the current is flowing in this? Because the circuit is closed. No, the current is not flowing. The bulb will not glow here, because we have, you see here, we have infinite resistance. The negative charge will be pushed by the voltage source from here to here, but here there is a barrier that these electrons will not cross this, because it is an infinite resistance. So we know that the condition from Ohm's law, I is equal to V over R, and so we have V over infinite is equal to 0. The current is 0, so there is no current flow. So it is replaced by open circuit. Here you can see there is no current flow here because of infinite resistance. There is no current flow. So finally I conclude that, so whenever there is an open circuit, there is no current flow, that is current is equal to 0, and between these terminals there is voltage, some voltage is there. Just remember that. We'll now go to the concept. So here let's take, you know that capacitor is made up of two plates connected, two plates, you can see these are the two plates, and between the two plates there is a dielectric, because this charge will not overlap with this, the charge in these two. So in plate A, so initially these two plates are initially these two plates are neutral, that is same amount of negative and positive charge, no more positive or no more negative charge, they have same amount of positive and negative charge. So after that, here comes the scenario. So when we connect to an voltage source, here connecting an voltage source, so this voltage push the electrons in the wire. This negative charge will come here. Because of this, here there will more negative charge will accumulated. So because of this push, there is more negative charge in plate B. So because of more negative charge, you know that the same charges opposed together. Here is, we have negative charge, and here In the plate A we have negative charge. This negative charge opposes this negative charge. It reflects this one, and because of that reflection, this negative charge travel this path, and they come here, travel this path, and they will come. This negative charge will come here, and here they accumulate. Because of more push, these electrons will come here and come here through this path, and they will accumulate here. After some time, the entire electrons which are present in this plate A will move to here through this path, will move to plate B. That is, after some time, this is only left with only positive charge. Plate A is only left with only positive charge, no negative charge is there, and plate B is fully negative charged. So here you can see, after fully positive and negative charge, there is no more electrons present in plate A, right? There is no more electrons present in plate A. So what now? No flow of here. There is more negative charge, and it pushes. There is no more electrons. Only this positive charge will attracted to this negative charge. So there is no current flow. We know that current is nothing but the movement of electrons, right? So after this is fully positively charged and this is fully negatively charged, there is no more movement of the electrons, because there is no more electrons in plate A. So that is, there is no movement of electrons, there is no current, so that is open circuit, right? So here you can see in detail. So initially we have two capacitor plates that is not connected to voltage source, and we have neutral charge in plate A and plate B. After connecting to voltage source, here the negative charge in this is travel through this path and present at plate B, and after some time, and some more negative charge will come to plate B, and after finally at last the entire negative charge in plate A comes to plate B. There is no more charge present in plate A to come to plate B. There is a negative charge, so there is no current flow. That is represented by open circuit, because there is no current flow, right? But the capacitor is fully charged now, so there is voltage present across that open circuit, because here the capacitor, you can see the capacitor is fully charged, so there is voltage present at that open circuit condition, but there is no current flow. So if you want to discharge this capacitor, so here you can see, if you want to discharge this, just connect to it and load, like a connect to it to load, like a connect it to a bulb. So now what happens is, this entire negative charge will travel through this path, and here they come here, because this positive charge attracts this negative charge. So the capacitor after some time will come to its original position. It's neutrally charged. That is the discharging of capacitor. So finally I'm going to conclude that